SwayamPrabha. Digital India. Educated India.
Hello friends, I once again welcome you in the course of Automation in Manufacturing. Now we will be studying the automated systems and equipment used in the manufacturing, that is a part 2. This is the lecture 3 of week 2. The outline of this lecture is as follows. We will be studying the CNC machine tools, various elements of CNC machine tools such as tool magazines, automated palletizing, tool wear monitoring systems. Then we will study a very important concept, that is adaptive control technology, and how the adaptive control technology is helping to build the modern machine tools. After that, we will learn the concept of automated storage and retrieval system. Then we will study the industrial conveyors, and at the end of the lecture we will study the industrial robots and its application in manufacturing. Now let us see how these complex surfaces can be machined. To machine these complex surfaces, we need to have computer numerical control technology. The CNC technology, or the term CNC, has 3 letters, C and NC. So let us see what is the meaning of NC. NC is numerical control. In this numerical control, we are using coded instructions. So these coded instructions do have various numbers, letters, alphabets and symbols. So these coded instructions will be passed to, or they will be fed to the machine control unit. Machine control unit is a part of CNC machine tool. Machine control unit reads these instructions and it follows that instructions, and by following these instructions it generates electrical pulses. That electrical pulses are running the motors of the CNC machine tool. So motors are the basic drives of the CNC machine tool. So the accurate passage of electrical pulses will be done by the machine control unit. Moreover, the machine control unit is getting the feedback from various sensors, and based on that sensor feedback it may take the decision to adjust or change or to vary the number of pulses that to be generated and given to the motors. So that we call the control. So the operation of the drives and control of the drives will be done by the machine control unit. So as the motors are running, we are getting the required operation. In CNC milling machine operation, the machining would be carried out. What exactly these coded instructions carrying the information? These instructions are having the information related to the distances. These coded instructions, they do have the distances, information related to the position, information related to the activation of various functions to carry out various auxiliary operations such as coolant on, coolant off, safety door on, safety door off, changing of the tool, So, all these functions will be carried out and these instructions are provided in the coded form. So, these all symbols, letters and numbers together are written in a standardized way that the writing way we call G and M code, the preparation and the miscellaneous code. We will be studying about this in the later classes when we will study the CNC technology in detail. Well, numerical control was started in early 50s in USA, and the instructions were written in the form of magnetic strips and punch cards. So, to write a simple program, it used to have very long length punch cards, and when we want to change or edit the program, you have to discard the entire punch card. So, that is very cumbersome, it is very lengthy process to develop a program and to write the program on the punch card. So, with the use of computers, this problem of editing has now been solved. So, the computers are helping us to have graphical user interface, and now we can write the program in an offline mode. So, you can write the program on computers. On computer console screen, you can easily change the program, you can easily edit the program. So, it is on machine and online programming has possible with the computers. In addition to the online editing of the program and online simulation of the program, we can incorporate now automatic tool change operations, automatic palette changing operation. The machine can communicate with other machines through network communications, and the machine can communicate with the central computer through network computation. So, either the communications may be done in a wired mode or the wireless mode. So, this is very interesting feature of the CNC machine tools. The machines can now run unattended. So, we will be looking at various tool changing, palette changing aspects of the CNC machine tools in the coming slides. So, tool magazine. So, in general, a typical conventional machine tool, so we can mount very limited number of cutting tools and we have to change that cutting tool manually. So, it is time consuming task. So, in CNC machine tool operations, we are using automatic tool changing facility that we call ATCs, and in addition to that, we should hold multiple number of cutting tools. So, if I take the example of a CNC drilling machine, the operation is very special that the machine tool should manufacture variety of types of the machine tool should carry out variety of the drilling operations from small to larger size of holes that to be drilled. So, for that purpose we may need to have large number of drill bits, we may need to have the large number of the semi finishing tools that we call reamers and finishing tools in a drilling operation. So, for that purpose various types of arrangements are available in CNC machine tool industry. So, some of the storage devices are seen on your screen. So, this storage devices is umbrella type storage devices. This is a circular magazine, and these circular magazines can hold up to 30 number of the tools. But if you want to store say from 80 to say 120 number of tools, then we are using chain type of arrangement. So, these ATC facilities, they do have the storage devices as well as mechanisms which are required to remove the tool from the spindle of the machine, that we call unloading of the tool and then loading of the tool to the machine. So, the removed tool will be taken to the magazine and that will be stored in the magazine at a empty slot, and the designated or the desired tool will be taken from the magazine and that will set at the spindle of the machine tool. So, that is the automatic tool changing operation. So, this saves lot of time and it enhances the production. So, production rate enhancement is the ultimate aim to provide the tool magazines. Now, next type of arrangement is required in CNC machine tool, that is pallets. So, pallets are used to stack, store, protect and transport of the work part. So, we need to stack the work parts or we need to stack the finished products, then store the work parts, and that stored work parts will be fed to the machine whenever and wherever it is required, to protect the work parts and to transport, to convey them over the conveyors. So, a typical arrangement can be seen on your screen. So, in this machine you can see there is a pallet. On this pallet various work parts are mounted and the machine will carry out processing, whatever the processing it may be, machining or drilling or it may be a welding. So, this processing will be carried out on the work part or it may be the washing operation as well. Once the operations are done, then either the pallets will be removed manually or by using robots. During the processing time, the other operator can ready the next pallet. So, here this pallet number 2 will become ready. So, here you can see various work parts are ready which are to be fed to the machine tool for the next set of operations. So, this again is saving the production time, it is reducing the lead time in the manufacturing. So, designing of the pallet or changing of the pallet, then changing of the pallet transport system or pallet changing system, it varies from machine tool to machine tool. Some of the advanced concepts are coming in the CNC machine tools. So, these are adaptive control. So, usage of adaptive control technology in the CNC operation. So, what is the meaning of the adaptive control? So, in adaptive control, the tool, machine, workpiece are protected from the damages caused by the malfunctioning of the machine. So, we have to protect tools, machine components and workpiece from malfunctioning or unexpected changes in the machine behavior. So, machine may behave in an unexpected way, maybe due to the failure of the tool. So, if you take example of the CNC milling operation, during the CNC milling operation there is a huge amount of friction that is occurring between the tool and the workpiece, and due to that lot of heat is generated at their contact point at their interface, and due to that there is wearing and tearing of the tool as well. So, tool edge will get blunt, due to blunt tool edge the friction will further increase as the sharpness is reduced. So, we may not get even proper surface finish. At certain point the tool may get failed, the edges may get broken down. So, that broken edges will harm the machine tool. So, therefore, we need to continuously monitor the tool condition. So, as we get the in situ information or in process information about the health of the tool, we can in a better way control the process. If the tool is getting worn out, the machine tool should give the alarm or the signal to the operator, or automatically it should take the decision to change the tool, or it may even adjust the process parameters, say speed or feed, that to be reduced or that to be adjusted by the machine tool. So, this concept is called as the adaptive control, in which the machine control unit has the capability to get the information from various sensors which are mounted on the machine tool for the monitoring purpose, and based upon the sensory input, the machine control unit will take the decisions to change the process parameters or to change the tool. Tool wear is a critical factor which is affecting the productivity of a machining operation, and it is very essential to take care of the automatic tool changing to have an automated machining system, which is the feature of unmanned factories. So, naturally the unmanned factories required uninterrupted machining operations which are helpful to achieve the desired production goals and to get better customer satisfaction. Yeah, so we have already seen that these unexpected failure are damaging to the machine tool and the workpieces. Then the question comes, what are the ways or what are the methods to monitor the cutting tool failures or to monitor the cutting tool health? So, basically there are two methods. First is the offline monitoring system. In offline monitoring system, the cutting tools are taken out from the spindle, and then these cutting tools will be observed under the tool microscope. So, special purpose microscopes are available. These microscopes will be used to measure various angles of the cutting tool. So, based upon the angles of the cutting edge and the surface of the cutting tool, the operator will take the decision whether the tool is to be replaced or the cutting edges are to be resharpened. So, that is the manual mode of the tool monitoring system. So, this system is time consuming and naturally it is enhancing the lead time. But the advantage of offline monitoring system that human operator can closely monitor the cutting edges, and by his or her experience or knowledge he can take the appropriate decision. However, as far as the adaptive control systems are concerned, nowadays people are going for the online monitoring system, that is the second mode. So, in online monitoring system there are various methodologies being used. So, in this system various options are available. We can go for acoustics or the measurement of forces or based upon the images. Acoustics is nothing but you record the sounds during the cutting operation. If the sound of the cutting operation is normal, it is standard, then we can say that the cutting edges are intact, they are fine. If there is unusual sound is occurring, then we can say that there is some problem. It may be either with the tool or with the workpiece. Accordingly, the operator will take the decision or the machine control unit itself will take the decision. The second way is by monitoring the cutting forces. So, when the tool edge is not proper, when the tool edges are blunt, so the required cutting forces are more. So, if we can monitor the cutting forces by using equipments such as dynamometers, then by getting the data from the dynamometer, we can easily take the decision to either change the cutting tool or to grind cutting edges. So, the input from dynamometers need to be conditioned, the signals from dynamometers need to be conditioned. So, amplifiers are required. We need to design a sophisticated data acquisition system, and that data acquisition system is helping us to take the required decision. Now, as far as automation in manufacturing concerned, the next type of equipment which is very common and which is very important, and that equipment is automated storage and retrieval system. So, as we have seen in the video, there is a rack and there is a stacker crane, and that rack and stacker crane are being handled automatically by the central computer unit. So, this system is basically used to store the raw material, tools, semi-finished products and finished product. So, when the quantity or volume of raw materials, tools, semi-finished and finished product is very high, then manual handling of all these material or commodities, it is very difficult. So, for that purpose we are taking help of the stacker crane and a storage device. So, a typical automated storage and retrieval systems are shown on your screen. So, here you can see these are all the racks. The racks has many compartments. The compartments are coded, numbers are given to the compartments. Then there is a stacker crane. So, for this row, here you can see this is the stacker crane number 1, this is stacker crane number 2. So, this is the conveyor, and that conveyor is taking the commodities to the stacker crane feeding unit. In the next figure you can see there is a conveyor over which the commodities are moving. The stacker crane is taking the commodities and then it will store the commodities in the programmed compartment or programmed section of the rack. So, automated storage and retrieval systems are helping us for the efficient space utilization, and they are providing us the optimized flow of the commodities inside the system. So, you can see here by using the automated storage and retrieval system, you can utilize the vertical space inside the factory. Well, the next type of automated equipment that is used in industrial automation is industrial conveyor. So, these are mechanical handling equipment, and with the help of mechatronics we are automating their operations. So, we need to convey variety of commodities, the raw material, semi-finished goods, products, finished goods, products, tools, many the auxiliary equipment or material required in the manufacturing. So, on your screen you can see a typical conveying system, that is a roller based conveying system is there, and on the conveyor you can see the baskets are there, and over the baskets the goods are mounted. As the baskets are moving over the roller conveyor and the goods are taking to their respective destinations. The automated or industrial conveyors are helping to have quick and efficient material handling. They are also widely used in packaging industry. So, various types of conveyors are used in the industry. So, we will see them one by one. First type is belt. By using belt we are conveying the commodities, belt conveyors. Then bucket conveyors, buckets are used. Basically bucket conveyors are used in coal or in food industries. Then roller conveyors are suitable when the commodities are packed in boxes, when they are having flat bottom. So, that can roll over the conveyor. So, roller conveyors are either gravity operated or they are powered. So, we are using electric power to drive them. The next type is chain conveyor, then we are using skate wheel conveyor, then we can have a screw screw conveyor, spiral conveyor, vibratory conveyors. So, vibrating or vibratory conveyors are used for sorting operation. So, we are conveying and simultaneously we are sorting the commodities. So, in front of you, you can see a overhead conveyor, and this overhead conveyor is used to convey the car body. The car body is mounted on a carrier, and that carrier is moving by a monorail which is mounted on the shop floor. So, in this way we can save the floor space, and we may have the easy movement of the heavy bodies which are hanging inside the shop floor. So, on the floor space we can do the other operations. The next type of interesting thing which you can see on your screen is the belt type of conveyor with sufficient the frictional coefficient to carry or to convey the food products. Of course, the belts should be of food grade quality, they should not contaminate the food products. So, potatoes which are to be moved on the belt conveyor are shown over here, which may be utilized for its processing further. Then in this case screws are used. So, stainless steel screws are used. Stainless steel is a good quality food processing material, and here you can see the grapes which are to be conveyed, and further they will be crushed to produce the wine. So, the grapes that are to be moved are shown over here. So, it is a stainless steel screw conveyor. Then we are having a very important automation equipment, that is industrial robot. So, industrial robot as per as ISO 8373-2012, it is defined as an automatically controlled, reprogrammable, multipurpose manipulator. So, this is a mechanical equipment controlled by electronics. It is a mechatronics based equipment which is reprogrammable. You can reprogram it for variety of operation. It is multipurpose. There are many applications of robots. We will see some of the applications relevant to manufacturing. It is easy to control. So, we can control it by using sensors and a feedback system. So, these kind of robots are having multiple axes, 3 or more axes are there, and it is a very useful equipment and widely used equipment in the industry. So, various applications of industrial robots are in welding of the structures, mainly in automobile industry, painting of the products, ironing. So, this is very useful application in textile industry, assembly, very useful application in all manufacturing processes. Pick and place, it is a material handling operation. It is used to feed the products inside the manufacturing facility. Palletizing, to prepare the pallets, and that pallets may be used for the storage purpose, to create unit loads on the pallets. Inspection, in coordinate measuring machines the robots are used, CMM. In testing, so variety of testing can be done on the work parts using the industrial robots. Why the robots are widely used, why they are popular? They do have high endurance. So, what is the meaning of endurance? The robots can carry out difficult tasks without giving away. So, they are carrying out hazardous and difficult tasks and they are not giving it. So many repetitive tasks they do carry out with speed and high precision. So that is why industrial robots are very important nowadays in the manufacturing industry. Various types of robots are used in the industry, and they can be classified based upon the type of movement, that is the degrees of freedom, or the application, that is the manufacturing processes. It may be for the welding, for the pelletizing, or for assembly, or any other manufacturing process operation. We can classify the robots based on their architecture. Either it can be a serial robot or a parallel robot. Many robots are used in the industry, and these three are the prominent robots which are being used in the industry: articulated robots, SCARA robots, and the gantry robots. So, what is the meaning of the articulated robot? These robots do have rotary joints, and they can do specific task which is programmed by the programmer. SCARA is also a very useful configuration, and the meaning of SCARA is selective compliance assembly robot arm. Selective compliance assembly robot arm is the long form of the SCARA robot, and the gantry robots are the overhanging robots which are used to carry out variety of tasks. Well, my friends, let us summarize the lecture 3 of week 2. In this lecture, we have seen CNC machine tools. We have seen various its elements such as tool magazines, pallets, tool wear monitoring systems. After that, we studied the adaptive control technology concept and how to build a machine tool based on this technology. Then we studied the automated storage and retrieval system and its usefulness in the advanced manufacturing system. After that, we have seen various industrial conveyors. Those are employed in the manufacturing domain. And at last, we have seen the industrial robots and its applications in the manufacturing. In week 3, we will be studying the fabrication and selection of various components which are required to develop an automated system. To manufacture or to fabricate an automated system, we need various processes. So, we will have an preliminary discussion on fabrication processes which are commonly used to develop automated systems. We will also study the use of CAD softwares for the design and development of automated manufacturing equipment.